Hello and welcome to this video. In this particular video we are going to study what is a stack. Now what is a stack? A stack is a linear data structure which follows the concept of LIFO, that is last in first out. It means the element which is inserted the last is the first one to be removed. So if you can see, the blue block comes in first, then the yellow comes in, followed by the violet one. So this is now a stack which has three boxes which has been inserted in the order of green, yellow followed by violet. Now if I want to remove this boxes from the stack, then it is the last one that has been inserted will be removed the first, followed by the second last, and then the green one. So this is the basic concept of stack, which follows last in first out. A stack uses one pointer to keep the track of the elements. And what is that pointer? That pointer is named as top. The pointer top is used to keep the track of the topmost element in the stack. The element is inserted or removed from the top. So this particular pointer top can be used to keep track of the element to be inserted or removed. The different positions of the pointer top can be: when the stack is empty, top is set to -1. So -1 indicates an empty stack. When the stack has few elements, then the top is said to be the last element that was inserted into the stack. In this particular case, top is 5, which indicates the last element that was inserted. And in case of a completely filled stack, the top is the extreme end of the stack. This is a stack of 10 elements, so top is 9. Now let us look into the basic operations of a stack. There are two basic operations in a stack. One is called push and the other one is called pop. Push inserts a value into the stack and pop retrieves a value from the stack. So let us see how these operations work. So this is a stack of n elements where top is -1 initially. Now as I call this push function with the value 15, top changes to 0 and the value 15 is pushed into the stack. Again, if I call another function push 36, top will again increase to 1 and the value 36 will go into the stack. Push 72 will increase the top by 1 and then the value 72 will go into the stack. Push 20 will increase the value of top to 3 and then insert the value 20 at the top. So you can see, every time a push operation is called, the top first increases and then the value is inserted into the corresponding position, which is indicated by top. Another push 40, top increases to 4 and the value 40 goes into the top. Now if I try to pop the elements from the stack, okay, one more push function is there. So push 54, top will increase to 5 and the value 54 will go into the stack. Now as I try to remove, calling the function pop, then first thing that will be done is the value in the topmost position of the stack will be stored somewhere and then top will decrease back to 4. So now 40 is the topmost element. Again, if I call this function pop, the value 40 will be saved somewhere and then top will decrease back to 3. One more pop function, the value 20 will be saved and top will decrease back to 2. So as you can see, it is whether the push operation or the pop operation, it always takes place from the top of the stack. Inserting a value in a stack. To insert a value in a stack, the first thing that you need to know, what is the condition of the stack. So first is whether it is the stack completely filled. So this is a completely filled stack and you can see the maximum element that can be stored in the stack is 10, and top has reached the last position, which is the index position of an array, which is 9. So we can say that if top has reached max minus 1, where max is the maximum number of elements that can be stored in the stack, then you cannot carry out the insert operation, so it gives a message stack overflow. Otherwise, if it is an empty stack or a partially filled stack, then the first thing we should do is increase the top by 1 and then insert the value in the top position of the array. Let us look into the code in Java. So the function is void push, taking an integer argument x. It's checking that if the top is equal to max minus 1, if the top is equal to max minus 1, it prints a message stack overflow. Else, it increases the value of top by 1, inserts the value x in the top position, and then prints the message value inserted into the stack. Next, we'll look into the deleting a value from a stack. Again, to delete a value from the stack, the first thing that we need to understand is the condition of the stack. It can be an empty stack where top is minus 1. So if it is an empty stack, that means there are no elements in the stack, so you cannot delete a value. So the message comes up stack empty. Else, if it is a partially filled stack, then the first thing that we should do is store the topmost value, which is 32 in this case, to a variable, and then simply decrease top by 1. So store 32 in variable x and decrease top by 1. Let us look into the code. The code says if top is equal to minus 1, that is an empty stack. Empty stack means top is minus 1. So we print the message stack empty. Otherwise, we are taking the value in the topmost position in the variables. So we are writing x is equal to s top. We are printing the value that is popped from the stack, and we are decreasing top by 1. Next is display the stack. To display the stack, it can be an empty stack where top is minus 1, or it can be a partially filled stack where top is, in this case, it is 5. So when we are displaying a stack, we will be displaying from the topmost element to the bottom element. So that is, we'll start from top and we'll go up till 0. So that is what the code is all about. The code says void display if top is equal to minus 1, system.out.println stack empty. Else, the loop that I have taken is from top, which is the topmost element of the stack, till greater than equal to 0, and we decrease the value of I. So I is equal to top, I greater than equal to 0, I minus minus, system.out.println s of I. S is my stack array, so we are printing the value in the reverse order from top to 0. So the next part that we are going to see is the execution of the code. We'll execute the code and try to understand the output of the code. So this is the execution of the code where there are 4 options: insert, delete, display and exit. The first option that I have selected is 1 and enter the value 10. Once more I selected 1, entered the value 20. And then again I repeated and entered the value 30. Then when I am displaying the stack, it is showing 30, 20, 10, that is from the top. Then again once more I insert a value 40, which shows 40, 30, 10 and 20 and 10. So as you can see over here, again the pop operation removes the topmost value, and then when I try to do the pop operation, it is empty. So this is the code.